Very well. So we have one more thing to settle here, and that is this idea that of the long-run supply curve. So far, we've been saying that when we use a long-run competitive model, we usually end up at the lowest point of the average total cost curve. But so far, we have been assuming that that lowest point doesn't change regardless of any change in the market. And that's a fairly strong assumption. So in this section, we're going to try to relax that assumption a little bit to give you a sense of the three types of situations that you can have in the long run for a particular industry. This, as you will see, when we talk on the conclusion, is going to become really relevant when we try to answer the question we initially posed at the beginning of week 5, which is how come goods such as computers and storage, memory storage, have gotten so cheap in such quick time. So here's let's go back to our model here, because it's a lot easier when we actually do it that way. And the more I do it, the more you guys get practice with this long-run equilibrium model. So we are right now, this is the market, and in one side, that the supply and demand of that and determines the price. And that firm, a competitive firm, they're all the same, selling the same thing, many of them, takes that price and do the best they can with that price. And in the long run, we're going to have a situation where the firm is going to produce at a point in which the marginal cost equals the average total cost and also equals the price. Right? Because for the firm, price and marginal revenue are equal to each other. So this situation represents long-run competitive equilibrium. This market is in long-run competitive equilibrium. Now let's suppose that there's an increase of demand in this market. So the demand curve would shift to the right. That would increase the price of the good, and that would allow the firm, the competitive firm, to charge a higher price for that good. This is P1 and this is P2. They will be able to produce more quantity, at least for the short term, because they're able to produce the good at a higher price. And since the price, which is right here, is larger than the average total cost, which is down here, this company is making profits. So the typical firm, the result of this on the short run, or this increase in demand for the product, is that the typical firm in this market is going to make profits. Now those profits are going to be short run or short term lived, because as other companies see that there's profits to be made in this market, they will continue to enter the market. And as long as there are profits, companies will continue to enter. And they will, as they enter, they will drive the price down to, again, the point at which the profits are completely eliminated. So that increase in the supply, again, drive the price down to the original point, which is the lowest point of the average total cost curve. And again, at that point, we are on long-run competitive equilibrium, where the price equals average total cost equals the marginal cost. And the economic profits are 0. So if we connect these 2 points, let's say point A right here with point B, we have what economists call the long-run supply curve. And you see that in the long run, this good, whatever it is, you're always going to have the same price, P1. In the long run, when the profits are eliminated, which is a competitive equilibrium, the price always goes back to the lowest point of the average total cost curve. So this will be called a long-run supply curve. It's a straight line, meaning that in the long run, this price is the same. Now, as it turns out, this is just one special case of an industry. And economists call this a constant cost industry. And the assumption we're making, again, is that the average total cost, the cost per product of producing this, doesn't change. Right? It's the same regardless of how many firms are operating in this industry. But that's a very strong assumption. I mean, consider a market such as, very labor-intensive market such as oil, right? Well, probably the more, or not labor-intensive, but capital-intensive in the particular case, the more companies actually try to extract oil, the more expensive oil becomes, because this is the main, and the more difficult it is to extract the oil from the ground. So here's a situation in which the more firms we have in this market, the more expensive it is to produce anything on this market. So what's happening here is that as more industry enter the market, the average cost per unit in this market increase. And what you will end up, if you actually follow the logic, is with a long-run average cost, which is increasing. And the more firms enter the market, the more expensive it becomes to produce anything in this market. And therefore, in the long run, as more firms continue to enter, the long-run price in this market is going to continue to increase. So that is a different situation than a constant cost industry in which the price is the same. That is an increasing cost industry. And again, I think oil or anything that is that is limited in resource or that it will require a lot of effort to do, the more people you have, that's a very good example of that. And I think oil is a perfect example of that, in which a very limited amount of it available, and at the same time it's so hard to extract it. So you can imagine that the more people are looking for it, the more expensive it's going to be to extract that oil from the ground. So that means that the more companies are operating in that market, the average cost of producing in that market, the higher would that average cost will be. So in the long run, as more firms enter the market, the price of oil should continue to increase. And that's what we have seen, right? You don't see a situation in which the price of oil is actually a lot less today than it was 20 years ago. It's not very different, but it's a little higher than it was 20 years ago. But that's a very different story of what we said about computers. That's a situation in which, as companies enter, they may find new ways of building things and take benefit of what economists call economies of scale. So perhaps when you have one or two companies operating in this industry, there's not enough, let's say, demand for implement a particular technological improvement or a particular assembly line. But when you have 10 or 20 or 40 companies operating in that market, now companies are large enough that they can take advantage of technological improvement, like the assembly line, for instance, right? The assembly line really reduces the cost of producing cars. And or the TV industry is another good example. As more companies enter in the market, the technology used to produce TVs actually gotten better and better. And the reason why is because when there were so few companies operating, it was not really cost effective for those companies to implement good technologies. But when there's a lot of customers and a lot of companies, then companies have an incentive to actually innovate, and that technological improvement reduces the cost of production. So when that happens, what is happening is that the average cost of production are going down every time more companies enter the market. So what you will end up with is a long-run supply curve that is downward sloping. Every time company enter or more companies enter, the average cost of production go down, and when all is said and done, you're going to end up in a point in which the lowest point of the average total cost is lower than it was before. So we call those companies decreasing cost industry. And you know, a lot of the major technological things that we have used in the past, I think, 100 years really meets that standard. Think about cars. I mean, cars were really expensive when they first came out, but no, not only the rich people can actually, are corrected for inflation. Only the richest people in the country were able to afford it. But now, a lot of people, more than before, as a percentage of the population, can afford a car. So in general, cars have become cheaper than they were 100 years ago. And the reason for that is because as more companies, as demand for car increased, and as more companies found it profitable to enter, a lot of the companies that were there were able to take advantage of technological improvements that did not make sense when there were only one or two companies. One of the major improvements is the assembly line that actually made car manufacturing a lot cheaper than before. But we see that in many electronic goods, like computers. We'll talk a little bit later at the conclusion. TVs, right, have gotten cheaper and cheaper. Music players, right? Flying, all those things that improvement in technologies have made the production of those things a lot more efficient. It's those situations in which the more companies you have, the less expensive it will be to produce those things. And ultimately, the benefits of that are accumulated by consumers that are able to buy goods that were before were not able to buy. So those are examples of decreasing cost industry. So the assumption that the company comes back to the original lowest point of the average total cost curve is an assumption that we made in order to explain the model. You have to be conscious that there could be three types of industries. One on those in which the more industries enter the market, the costs don't change. One in which the more industries enter the market, the average cost per unit increases, and one in which the more companies enter the market, the lower the cost of production are going to be. And depending on which of those three you are, it will tell you what happens to the long run price in any of these industries. Okay, so you have a lot of chance to use the model one more time. This is pretty much covers everything we have to cover now. We have to go back and close the week by trying to address some of those questions that we introduced even not only at the beginning of this week, but at the beginning of week 5.
Produced by OCE Atlas Digital Media at the University of Illinois, Urbana-Champaign.